Okay, so today we have this session on contributing to open source, right? There are viewers both on YouTube Live as well as in the Google Meet. I will request everyone to just text their friends and all if they're still joining because I'll be starting with the content really soon. And today it's less of slides and more of hands-on, like telling you how to use advanced concepts in Git and contributing to GitHub like in a better way. So I guess this will be a more fulfilling and satisfying session in that sense. So I will start in a couple of minutes till we have more people on the Google Meet. Those on the YouTube Live can please drop a hi or something there. All right, so it's 5 minutes past 5 already. Uh, those who are on the YouTube live stream, if you have the access to the Google Meet link, you can join in for an interactive session. So let us start with just discussing how to contribute to open source, right? Last time we talked about what the open source philosophy was, what open source software is, and the other things. And we also discussed some basics of what Git was and what GitHub was, as we discussed. Git is to GitHub as email is to Gmail, right? So those concepts. And we also took a short look at this particular tool where we can visualize how Git works, right? If we do a Git commit, we can change from one state of the project to the other. So we will carry on from this point where we know how Git works, that it maintains state of the project directory, and then move on to the advanced concepts that we will be using in Git, and that will allow us to be better contributor. So let us get started. So this session is called Git and GitHub 102, right? 102 in the sense because we have already covered a lot of basics in 101, what open source is, what Git is, GitHub is, and I've shown you the user interface for both of these. Git is usually used from the command line, and GitHub is a website with a web UI. 102 because is the next step. So we already covered some Git commands in the last session. We did git add, git commit, and git branch, git checkout. We will just review them very quickly and also cover a few commands that we left out. For example, git clone, push, pull, and these things. Okay. Is everyone on board with me? Can I proceed? Okay. So, you know what the git commit command does, right? If we do git add, it just adds all of the changes that are there in the current directory to the stage that Git maintains in its own .git special directory that it creates. We have discussed all of this in the last session. So when we do git add and git commit, it creates a new state like this. We also know that we can make a branch from the current point where we are, where our main pointer is or the head pointer is, to some other branch. For example, if I want to like create a branch called temp, I can actually create a branch called temp and move to it. And if I do git commit at that point, it will add that particular commit to the temp branch. And again, if I come back to main and do a commit, it will add this commit to the main branch. Then we also, for a brief period, we saw that we can also merge these branches, these divergent branches, in this particular data structure that it is maintaining. So right now I am on main. If I want to merge the temp, the commit and temp branch, that is C4, into this main branch, I will have to do this, right? Git merge temp. So what it does is it merges all the changes from the temp branch as well, that is in the commit 4, and it merges it with the commit 5 changes, and we have a new state that is commit 6. So all of this was discussed the last time we spoke to you. This time I am going to demonstrate a few other things. For example, git clone, push, and pull. So the git clone command here, what it does is, we discussed the concept of a remote and a local repository. I said that GitHub uses the Git service, like Gmail uses the email service. So an email server runs on the Gmail servers. In the Google servers or Yahoo servers, there is an email server that is running SMTP with SMTP, IMAP, and POP3. These are the protocols that email servers usually use, right? GitHub also has a Git service that is running on its remote machines, on all the data centers, on all the servers that it has. And your system is also running Git. It also is using Git to track the changes, right? What clone does is, it just you just supply a remote, you specify a server where Git is running, and you want that particular folder or that particular project that you want to be synchronized with your local machine. That is the task of git clone when it is being done for the first time. This folder does not, any folder does not exist on your particular local computer, but it exists on the server that you have, and you want to just copy all the source code that is being maintained on the remote server on your local machine. That is the task of git clone. So let us find out some any project on GitHub, and let's clone a particular project. For example, I was going through this particular extension that is there. I think it's presenting.vim. This is a software for creating slides, slideshows, PPTs in the command line, right? So if I clone this, you will see on GitHub. But now the remote server, the server that is not on my part, on my local machine, that is the remote, right? So we are using GitHub as remote in this particular example. So I know presenting.vim is a folder or a project directory that is there on the GitHub servers, and I want it on my local machine. I will go to this code button and I will attempt to clone it. You could also download a zip file, but zip files will not have any information, like you cannot make any changes, and that will not be tracked by Git basically. If you want to use Git going forward, you want to contribute to this project, or you want to like download new updates to this project as they are like pushed, uploaded to the remote server, you need a reference, right? You need to clone it, not download it as a zip. This is the correct way to do it, is to clone it. You will see a few options like HTTPS, SSH, and GitHub CLI. So these are the different protocols or the different ways you can do this. It gives you an URL. If you use an HTTPS link, right, it gives you an URL that ends in .git extension. And this is basically a pointer that can be used by Git to copy or download all of those project files onto your local machine. You can also use Secure Shell. This is another protocol for doing kind of a similar thing, that it will clone or synchronize all the project files in that directory to your local machine. All right. So in this example, I will be using this HTTPS URL. In order to clone a repository, first we have to like open up our terminal. We know that Git is installed. right? We configured it and used Git a bit in the last video. So right now I don't have any important folder in my current directory. Where am I? I am in /home/Ubuntu. This is the absolute path for where I am. These are some hidden directories that are containing like configuration files and stuff. We don't need to look at it, but we don't have any other files. In order to use git clone, we have to write this command, right? Git clone. And then we have to supply the URL here. The URL goes here. I pasted the HTTPS link that has the .git extension at the end of it. And when I execute this, it says that cloning into presenting.vim. So by default, what Git does is if that particular project does not exist on your local machine, it creates a folder with the same name as the name of the project. So what was the name of our project? Presenting.vim. Saute. This person is the author of this particular project. But presenting.vim is the name of the project. So that folder has now got created in our local directory, wherever we are. So we have presenting.vim folder here. So if I go into that folder, I can see there are more folders inside and there are other files as well. So this contains all the files. When I do a recursive listing of all the files in this directory, so I see that there are some GIF files, some markdown files, and other stuff. So what it means is all the code that is there on the project is now available to me. This is the project. Okay, so we have now cloned it. Cool. Let's move forward. Git push and git pull. Assume that you have this particular data structure that Git is maintaining on your local machine, right? It has a graph of its own. The remote machine or the server that you don't have access to might not have the same graph that you are working with. And that is important. So let's say that this is the kind of graph that you have locally. But if I just open another tab and do, let's consider this. So this is, let's say, the graph that is there on the project directory, project server. In the server, this is the graph, whereas in local machine, this is the graph for the same project. So what do we do here? We want to reflect all of these changes on top of this particular graph. This is like totally taken care of by this push command. Git push is how we execute it. To take the graph that is there on local and merge it with this particular graph that is there in the remote. It does the opposite thing. It uses the graph that is there on the remote and tries to like merge it with the one that is on local. I hope the terminology, the terms I am using are not that complicated. Is everyone all right with all the terms that I am using? Right. Okay. We already know what git branch and checkout does. Branch creates a new label and checkout moves up the pointer around. So for example, if I have, if I just do, right now I am on C6, right? If I do a git branch temp2, it will create a new label for it. But I can check out wherever I like. I can check out the commit C0. So the head pointer will go there. We know how this works. The next command is git remote. I told you that the remote server is also maintaining the code. But your project might be stored or have different versions on different remotes, in the sense that there are multiple servers, let's say, that are hosting the same project in case of backup, or maybe some other team, maybe a team in India is working on some version of this project, and some other colleague of yours is in some other location and they're working on another version of this project. I mean, they have the same project, but they are maintaining their own copies on different servers. What do you do in that case? So for that, we have a concept of remotes. So Git has a pointer to all of these different servers which contain a copy of this local repository. So if I go to my terminal and do git remote, it says there is something called origin. I'm doing -v here just to show more information what it is talking about. So you see, it says origin, then we have the same .git URL that we cloned, using which we cloned this particular project for fetch and push. What happened here was that when we did git clone, it used this URL and gave it a label. This is a pointer, right? This is a pointer for a resource on the internet. It gave it a label called origin. It can be anything you want. It can be DUCS, it can be test123, whatever you want. And what it is saying that when you do a push to origin, this label, this is just a label for this particular entire URL. So when you do a push, by default, you will push to origin. And when you're doing pull or fetching the changes that are remote to your local, you will be using origin. I can add other remotes as well. Right. Let me see if this is possible. So what I'll do is, I'll see this same project might have different versions, right? Let's say Marek here is using another version of the same project. I could have also cloned this, right? It's the same project, but different versions. So I am adding Marek's version. I'm adding a pointer to Marek's version with the label Marek. What happened here? We have two remotes. As you can see, we have two labels that are given to these two different versions of the project. All right, this is the work of remote. If you want to know more, you can just actually do a man get remote. And what it does is it manages this command manages a set of tracked repositories. So these are the repositories. Basically, these are two unique URLs. These are the pointers that Git is maintaining a data structure for. That it knows when you want to push to origin, it will do it to this URL. When you want to push to Marek, it will do a push to this URL. This is the entire concept. So these are still basics of Git. This is not GitHub. This is Git. We are working with the data structures here and using pointers. Yeah. We also covered some concepts on GitHub, like what is a repository, basically a project directory that is maintained. Issues, for example, bugs that you might have in a project. Pull requests, we already covered that. It means a set of changes that you want to propose to an existing project, and you want the owner of that project to know that, okay, these are the changes. I want to merge these changes on top of your particular code. And now everyone should know that I have contributed this much code to your project. This is the concept of a pull request. Then there is COC. Let's cover that today. Okay. Everyone, all right? Is everyone awake? Yeah. Nice. Okay. I'm opening up a particular document. Right. This is an example of a code of conduct. COC. Code of conduct just formalizes how you should behave on GitHub. Now, this is contributor covenant. That means it's just a group of people who came together and named it a project contributor covenant. But usually, every other project will have a similar kind of code of conduct. So you should always keep these things in mind, that you have to be respectful towards other people. You should be kind towards other people. You should be an empath. You should do what you are told to do, right? And you should accept that if you have any errors in your proposed changes, you should accept that. You should discuss that instead of arguing with another person. You should not DM people. You should not violate their privacy and all of those things. That is the code of conduct. It is very important because people usually tend to ignore and do what they want to do. So, repositories, issues, pull requests, and your code of conduct. The next thing that we want to dive into on GitHub is using forks and conventions. Okay, what is this? Forks and convention. What is a fork? As I said, that a particular project can have different versions of it hosted at different places, right? All of those are forks. Now, this fork, that is a version of a project, can belong to you. It can belong to all the people who can access the source code of your project. An example, right? This presenting.vim is a repository, and all of these different people who have created their own different versions of the same project, these versions of the project are called forks, and you can see that there is a line called forked from sorte presenting.vim. It means the original project was sorte presenting.vim, and this is just a version of that. These are forks. This is important, knowing the concept. When you actually contribute to GitHub, now here's where the practical part starts. You figure out a project first, right? I have an example project for you today that you might be familiar with. I hope people have used this system in the past. Give me a thumbs up. Right. So this is a project, DUCS voting system. We don't want to know what it is, what the project is about. We are just seeing what we can do with it. Right. There's a button called fork that says that fork your own copy of DUCS voting system. What it means is I can have another version of this particular project running elsewhere. Now this particular name is already taken, right? I'm just adding this. So this is a fork, and this repository already exists here. So maybe what I'll do, basically what it means is that I already have this particular project on my account. So the GitHub remote is not allowing me. Okay. The GitHub the Git version that GitHub is running is not allowing me to create a fork there. That means you cannot have two versions of the same project in the same under the same account. There is a reason for this. The reason being, you know, Git works with data structures that have hashes. So a commit with the same hash cannot exist on two different folders under the same account. So that is why it is saying that choose the owner first. Here I'm just using it for test. This is the computer science society of my earlier college that I was in. So I'm creating this fork under that owner. I still have access to this particular uh, organization on GitHub. It says that it's forking. It is creating a copy. Project. Cool. It has created a copyright, and it says that this has been forked from Sudipta G81, GVC's voting system. This is a fork of this particular project, and if I see, folks, there is no fork here, but if I go to, I do have a fork here. It takes time sometimes to actually have it show up. I can also clone this particular fork. Right. So what I'll do is here, I will go back to my root folder, my home folder, sorry, and I will clone this particular project. We know how it works, right? We also saw we can use the git log command to see what are the different commits there. It shows us a graph if we want to. Right? This is the graph of that particular project. So right now we are on the main branch. If I do a git remote, I can see this is the origin. But let's say I also want to keep track. I also want to keep track of the original project that it was cloned from. I do something, right? I will add another remote called upstream. Why upstream? This is just a convention that the code that is originally there, if you add a reference to it, you use the word upstream. If you are like referring to the code that you are working on, that is usually the origin. That is the version that you are working on. That on the local system, you refer to that as origin because that is the one that you're working on. So if I do a git remote -v now, I see that there are two upstreams. There are two remotes. One is the origin and one is the upstream. Interesting thing is here, to the origin, I always have access. I could have done it from another account, right? Just created a test account for this demo, but still. This is the one I always have access to. I can push to this repository. I can pull from this repository. I can upload and download from this repository. This particular repository, this particular version, I may not have access to upload to. It makes sense, right? If it is a bigger project and if I just do some local changes and I want to upload it, it will fail with the upstream. In this case, I do have access, but usually you don't have access to the upstream. You don't have push access. You should still have like the fetch or pull access because there might be an update that is there on upstream. The original project received an update and you want to just integrate those changes on your active copy, the one you are working with. So that is why usually upstream fetch is there, but upstream push does not work most of the times if you don't have access. So that was the concept of forks. All right, we come to conventions. This particular way of saying one is origin and one is upstream is a convention, right? But have you noticed that when we are doing all of this, we are using something called main as well? When we started this particular website, it started with main. So this is also a convention nowadays that a repository always starts with a default branch that is called main. That is there. We know what commit messages are. We have some changes, right? We always add a meaningful message that what are the changes that we did. We updated readme, we added something to a particular file or added a file. That is fine. But usually in the open source, the larger open source projects, they use some standardized way of doing those things as well. They use some conventions to even write commit messages. So for example, you can have fix, feat for feature, docs for documentation. You are doing some CSS changes, so that is just styling. You increasing, you're optimizing the performance, you're adding some test. So all of these, like this is how you will actually do the message when you will do this command, right? Like git commit, you will do something like this. What changed here? Instead of adding an informal message, you're actually specifying what part of the code you have changed in this particular commit. And it makes it easier for other developers to actually keep track of the work that you're doing. It's fine. So that was conventions about commit messages. There were conventions about like creating own branches and all. So when you usually do this branching, you have this main, right? And when you clone a project and you do a certain type of work on it, it is usually recommended that they say that you should create a branch with your GitHub username. Let's say Sudipta G81. So this is the project that I am working on. So Sudipta now wants to add some changes to it. I would usually do this, that add the date as well. That yeah, so this is a simulator, so they have truncated it to these many characters. So now Sudipta can make his own changes, right? Then when it is time, he can propose all of these changes to the owner of this particular project, and they will then what they will do, they will go to main and they will just merge, right? So now all of those changes are now integrated into the main project. That is how a contribution would have worked. Okay, let's do some things. Let's do some things and then we will go back, go to the advanced Git concepts. I have a plan for this particular project. Okay, the UCS voting system, right? But I want to go to its scope, like that's on the RST. I'm duplicating this tab and going back. I did a few issues here that we will solve. So as you can see, I have added some enhancements, some documentation issues that are there with the project, and I'd like people to resolve it, right? So what I have done, what would have been the case with the open source project? If there is a larger project, they will have a title. This is the issue title, right? And what is the problem? Add information on courses to readme.md. I don't know anything about the project. I don't know what he is talking about, what Sudipta is talking about. But they have said that a line about the course relation is missing in README. It makes sense to cover that. Relation, that means sub database is being used there. We'll have to go through that and we will have to review that what is written in readme.md file and what is to be added, that we have to figure out on our own. Here other people have like jumped in on the issue that can you please assign me this issue? Can I work on this particular thing? They have mentioned this, right? Let us resolve this issue. Let us fix this issue. We don't have information on courses in readme.md. So what I'll do is I'll open this code. I have cloned this DOCS voting system. Sorry. Yeah. I've opened this. I've cloned this DOCS voting system on my server. Right. I'm opening this code. Okay. So if I do a git remote v here, I see that there is an origin and an upstream. Let us see what happens. Currently, where are we? We are on the main branch, right? It is usually recommended not to touch this main. Why? Because if you do some changes to main, and then propose these changes to main directly to the owner of this particular project, they might be like, okay, wait, a lot of things are happening. I might want to like test it out on a separate copyright, on a separate branch. I want to keep my main very secure and very stable because people might be downloading from it. So that is why it is usually requested and usually encouraged to use some other branch name. So I'm using this git checkout b. Let's use dev. I am doing some development, and today's date is 29/10/23. What issue are we fixing? This is the issue number 5, right? I usually do this. Add the issue number as well. So this particular branch that I have just created is just for this particular part of the fixes. I will touch nothing else. So we know which file that we are talking about. We are talking about this readme file. We have to make the changes here. You see, there are a lot of things happening here. It is basically a documentation of the project. We have some notes, we have some features, we have some instructions. We see that the list of students who can vote, blah, blah, blah. All of this is there. Where is the database schema? So I know about this because I've gone through the project before. So in schema.prisma, you usually have the relation information here in this particular project. So you can see there are 4 models: course, vote, candidate, and user. We have information about user, candidate, and vote here, but we don't see courses being covered. I can just be a very innocent person and just write this: the list of courses is stored in the relation in the database. This looks very nice, right? This is what we wanted to do. This was the only change that was required. So if I do this, what will happen? Status, we have modified a file. We want to add that. Git add dot. Git commit, what I'll do? What is the message? Docs, add info about courses in readme, about the course relation. It's very self-explanatory, right? This is done, but this is still not visible on the either. I'm doing this on this dev branch, whatever I've created on this version of the code. I'm not doing it on the main. If I do a push, it asks that there is a, it first says that there is an error. I have to push it to some remote. I want to not do upstream. I don't want to do this. Instead, succeed in this case, but usually it will fail with a forbidden error 403. But what I want to do is I want to push to origin. What it says is make sure you have correct access rights. So there was some glitch that happened here and it considered U origin. We want origin. We just want this. It then asks me the username for GitHub. I provide that. Asks me for the password. I provide that. So it says that denied. That's sad. Let's see what happened. Saying that what are the access, what which people have access to the particular repository. I'm just signing in to this particular. That can actually push to this. This is what it will be for you. As I said, you should not have access to the upstream. You should have access to the origin. In this case, because we are working with other stuff, I usually have access to my code. Like origin, you will have access to. The upstream, you should not have access to. Okay. Can I do this again? Okay. Right. Let's see. Let's debug this. We were able to clone from this. We are not able to push to this repository. I have to check my email to accept the invite, I guess. Yeah. Okay. So we'll have to do this here. I have to get the password for this instead. Let's do it on the side. Okay. So I need a password for this. I'll have to go to my personal account here, and then I'll ask for the password for this organization. This usually won't be the case for you. So what I'm doing here, I'm creating a password for Techathon ARST for all the repositories that it has. It then gives me the password that I can use temporarily. It still doesn't work. That's sad. Bloopers do happen. Aha. Can I do it on upstream? Let's do it on upstream. Let's do things the other way around because we have to get going. Right? Let's do this to upstream because this is clearly not working. But even this is not working. Okay, why does this happen? Maybe there's some issue with this. Ah, nice. I do have my user information in here. Okay, let's do this. What I'm doing now is using some other form of authentication using SSH keys. GitHub recommends this format. Passwords is not recommended anymore. Okay, so it created a key for me. I have to now get that. So this is the public key for my account. Go to the settings and add this public key. So again, uh, yeah, access this. Right. I'll do one thing. Get remote. Remove origin. Get remote. Remove upstream. You can see the changes that are happening on the config. Went away. What I'm doing is, instead of using the HTTPS URL, I will use the the other protocol for actually doing this. This is correct window. Yeah. And if I change this to Sudipta G81, it will. I use this for upstream. Git push upstream dev. Okay. Okay. For some reason, it's upstream. Okay, this is working fine. Okay. There are errors that we have encountered. This is happening because of some glitch, I guess. Yes. Okay. So it worked. It worked finally. What we have here is that there has been a new branch that is created on Python ARSD account. That is this dev. If we go to main, this is just a fork, right? This is a version. This is up to date with the original version of the project. However, if I go to this other branch, this is one commit ahead. So the graph, or like, there is a new state that is there in this dev branch. What we want to do is now integrate that into our original project and tell the owner that, okay, all right, we have worked on this particular project. Now I want to fix your issue. Indication that this branch has had pushes. I'll click on this compare and pull request. We now have to open a pull request. And let's say I will do this particular pull request addresses this issue. It closes this issue. If I integrate these changes to your project, these issues will be gone. Just for being more organized, I can do these labels. I can add these tags that I haven't touched the code. It's just a documentation that I've done. I've added just one line. So I create a pull request. From hackathon to okay. It says that there are no conflicts. It can be like merged into my code. When I do this, it will create a commit. That is a new state that has been derived from these two different types of repositories. One was on Techathon and one was on in the particular project. Now you can see that there are only 3 issues. What happened? As I was demonstrating last time, this issue got closed automatically. Why? Because in this particular pull request, I had mentioned that it fixes issue number 5. But now when this pull request got merged and integrated, it has actually fixed the issue. So that is why it got edited also. I think I wrote fixes, it got edited to fixed. And that issue got closed at the same time. This is a contribution. This is a non-code contribution to open source. That now, particular project, your maintainer or owner, that they can just write that thanks for fixing this issue. Like, this could be one of the comments that you receive. Okay, all right. Let's move on. Let's do some more. I can also set up GitHub Actions for CI. This is a code contribution that will require some code. I can also add other things like contribution guidelines and issue peer templates. I think I'll pick up this one. So this is about how to contribute to this project. These instructions are missing. And again, you see that if I create a new issue, I don't have anything to work with, right? If I don't know about code and I don't know what is the exact issue, how do I communicate that with the developer? So this issue is particularly asking you to create a template that the users have to just fill out. It's just kind of a form. Create a form for filing issues. It's what I am asking for. So let's go back. So we are on this dev branch, right? Let's go to main. Right now it knows that only this particular main is there, but it is not correct. There are changes that have happened on the upstream. So I'll do a git pull here. It will say that there are no changes because this is what? There is no first of all, there is no tracking information, obviously. But in origin, that is the Techathon ARSD account, there is actually no change. The change that happened was on Sudipto's, the original project's main branch. So it is already up to date. But if I do this, which is misspelled for some reason. Okay, there are some issues. What happened? Okay, this was the issue that happened. There was a extra uh, colon in the get config file. Okay. Now on upstream, we should have some changes. Right? This is there. But still, see this now. Now when I pulled the changes, it also integrated all of these changes into my main. What were there on the upstream main? If I do git push origin main now, it will again push all of these new changes that are there from the original project and then just update it. There is a total 1 delta. That is, there is one change that happened on the original project. So what I want to do now is I want to create a new branch, which is again 29, 10, 23. What is the issue count now? Which issue are we solving? This is issue number 2. If I do this, now I have to work on this particular thing. I have to create a file called contributing.md. Let's do this. Contributing.md. This is the file. We have to come up with the content. Fortunately, I do have the content for this particular file, what it should be. Some content that we have. And we are also introducing another file called code of conduct. Okay. We also have the content for this. This component that we just talked about. This is the only thing that was asked for. First, we will do git status. We have added 2 files, but was it the only thing that was asked for? We have to add issue templates and pull request templates. We have to check out the GitHub documentation. So when I filed and when I was actually opening a new issue, it was giving me a blank text box to write what my issue was. But usually there is a better way to do all of this, and this is the concept of templates. In this project, they don't tell you how to write a pull request or issue template. This is expected that you come up with somehow you find out how to do this. How to do this, you can learn about more in the GitHub documentation, because they actually have this, right? Configuring issue templates, that you have to add these files. This is a example issue template, issue form. To do this, like, we have to integrate all of these things, these features of GitHub. So here, in to solve this issue, we have to add issue templates. Issue templates are usually added in this special .github folder, where we usually organize all of the things that are related to GitHub, all of the UI stuff. Bug.yml. If there is a bug, what should the user see? I'm doing this, that if there is a bug, I need your browser, which browser you are using, which operating system you are using, and how to reproduce the issue that you are filing for. For example, if there is some new feature that you want in this project, that should also be covered. So either you can have a bug or you can request a new feature. We'll not get into the details what they are actually trying to say. A pull request template. That when I actually wanted to integrate the changes, it gave me a blank form to work with, right? I don't want a blank form. I want a form that is already giving me like idea of what to actually what to write. So I am creating this file, pull request template dot markdown. This will have the description. How do I know your changes are valid? It is correct code. What are the issues, different issues? Is there any checklist? Have you gone through the code of conduct? You have added some information or not? This is that stuff. So, okay, I've done this. Right. This. Now I want to just add all of the changes. This is again docs. Add a contributing guide and issue peer templates. This is a mention that a commit message cannot have over 50 characters in the message. Right? So it's giving me this warning. So we have committed this now. And now I can publish this branch on origin, because this is the code that I have access to. Okay. This is done. What happened here is now there is another branch that has been created, which has all these no files like contributing and all of these files have been added now. Okay. I want to integrate, I want to tell the owner of the project, see that I have done what you wanted. Please let me now contribute to your code. Notification that I've added this. This fixes what? This fixes number 2. This is also documentation. So we'll do this. Created this pull request. And let's say the person who is actually the owner of this project, they say that, okay, it's all right. Let's approve this. Looks good to me. Yeah, pull request authors can't approve their own pull request. That's fine. But it's only me. I can do this. I can just directly merge this, right? I have merged this particular fix. Okay. Now I only have 2 issues. 2 others. Let's see what happened. We did some changes, right? We added some feature to this project. What was that feature? Adding contribution guidelines. Is there any contribution guideline? Yes. Right. This is a contribution guideline. There is a code of conduct. And you can see there is a new icon that is there on GitHub. Code of conduct. If I click this, it's opened up. These files we have added to GitHub. I create a new issue. Now I have a menu. I put a bug. Okay. Right. I get a form for this. I actually get a form how to do this. Or I can suggest a new feature. This is how you contribute to the particular project that they asked you to create this form for them. They didn't have this workflow. They didn't have a way to get people to report bugs, because if I just do a new issue and it gives me a blank text box, I don't know what they're asking for. And I can just keep the text box blank and just say that, okay, error, I am having some error. That's not an issue. I don't know what the issue is, right? So these are some kinds of contributions that we did live. So what happened was, now this time let's do another contribution, because we have added a pull request template and we want to see what has happened. So I will do on my code. Let me do this. Git checkout main again. Git pull upstream main. because now that main has changed again. There's a new version. All of these files have been added. Git push origin main. I am just synchronizing my active version from my local to the remote. So now Techathon ANSD's DUCS voting system is also up to date. Now I wanted to add a new, fix another issue. So this is dev 29, 10, 23. What issue we want to fix? That is issue number 3. Okay. What do we want to do? Add something. This is something that they want us to do. Set up a pipeline. Learn more about this here. It allows us to actually test our code or like run syntax checks that whether the code is correct or not, things like that. You can automate a lot of things using GitHub Actions. So they want a pipeline, continuous integration pipeline, so that the code that people are submitting, is it that the correct code or not, is what we are trying to see here. So for that, we have to add a GitHub action. GitHub actions are added this way. So I'm not teaching you how to use GitHub actions, how to, and what is the issue template and all. I'm just showing you how do you contribute new files, new code to a particular project. It's just that. So workflows. I'm adding a new workflow. I've worked with GitHub actions. That is why I'm able to do this at a faster pace. So what will happen is, it says that whenever people do contribute to your project, what we should do, we should first install all the dependencies and try to compile that project. If the compilation fails, that means there is some error, right? So that can be told to the person who is contributing that you have some error in your code. We want this to be there. So this is CI add workflow. Change. I publish this on origin. So on Techathon ARSD now, I have this another new branch. The code. I add a pull request. Now you can see, I do have a template that is already ready to go. This is what we contributed to the project earlier. So I am picking all of these checkboxes that we have done all of this. Related issue. This fixes number 2, I guess. No, number 3. This is fixes number 3. We can also delete all of these things, but this gives me something to work with. We know what to actually write in this box. So this is an enhancement I'm doing. Okay. No conflicts again. I can do the merge. This is merged. That issue is closed. We know this, right? Now we have an action called CI. It has run. It is running. Something is happening. What is happening? Build is happening. We told GitHub, whenever a new commit occurs, whenever someone makes a change, please run the code once. Okay. But for this, you should remember we added these things, right? There were some secrets that are there. I'll just fix these issues quickly. It's just that we need some more information, secrets, so to say. Doesn't matter what you use here. You just have to tell the project owner that what secrets they have to add because these are some variables that are required in the backend. Okay. So I've added this. Let's see what happened. We received an error. So this code is not right. The code in its current form is not right. What happened here? There was a non-empty, this environment variable was not like given to us. That is fine. We know this. Why? Because the secrets were not there. I added the secrets later. But now it will automatically compile. It will automatically compile the code whenever someone makes changes. So this issue is now fixed, that we have given this project the ability to run all of these things. So let's go back to our presentation now. So we have covered a lot of things today. Right. We fixed some issues. We did some contributions. We made the project better than what it was before. We added some value. These are called valuable contributions. Now, these do matter. If you just fix a spelling mistake somewhere, and that is the entire contribution that you make, that might not be a good contribution, right? But here, you actually added some features to that project. Let's quickly do these things some advanced Git concepts I wanted to cover, and I'll do it in this session only. Sorry for making it run longer than expected, but let's do this. Let's understand the other nuances. Okay, Git status. Where are we? We are on branch this. Right. Let's go to main. This is Techathon ARSD's main. I added some code here. Let's say test.txt. I added some file. Now, I want to actually pull this upstream, right? I want to merge, synchronize my code. Git pull upstream main. Okay. Its status. It still says that that test.txt file is there. Now my mind changes. I want to work on another project and create another branch and go there at this point, when this file is still not committed. Okay, this file is still not committed. I have added it to the page, but I have not committed it. Okay, at this point what I want to do is go to a new branch. You cannot this is main, where this file is there, right? Let me remove this file again. Git status. This file will still be there, and I'll change the branch. What happens is, git status now, you still have that file, but you don't want this file to actually linger around. This file should not be there right now, because I created this file on some other branch and it is still there. Let's say in this branch, in dev1, right, I have a lot of branches now. What are the files? I changed something to, let's say, yarn.log. Add some changes. At this point, I want to go to main. This yarn.log file has been modified. I don't want this modified tag to be there on main, because now I am working on main. Why should I be bothered about what happened on dev1? So I'll go back to dev1, do this command, git stash. Okay, what happened? That modified yarn.lock modified thing is gone. If I now go to main, I still don't have that. Yarn.lock modify file was modified by me. It's not there. Let's get rid of this test.txt. It's not adding any value. So it's clean. But I want that file now because I was doing something important for that time. I can do another thing. It's dash pump. So the file that I changed is now again appearing. For a temporary period in time, I was able to hide the changes that I did. I had modified the file yarn.lock. For some time, because I wanted to work on some other branch, I marked that change as hidden using get stash. So stashes the changes in the current working directory into some sort of a stack. And when you do a stack pop, it brings all of the changes and applies it again. So, right, that is taken care of. That is the work. That is why git stash is important. Git merge, we have already covered because we have seen how branches are merging together. Okay. Go to this. Git commit. Git commit. Git commit. I've just added 3 more commits. Let me add one more. I want to do something. Let's say someone said that if you have added so many commits, it will show your name multiple number of times that you have incrementally added these changes, made small changes over time. I just want a combined change that you did on top of what was done on C3. Like after C3, I just want to get to what C7 is, right? C3 is here. C7 is here. I don't want to know what you did in between. So for that, we do something called squashing or rebasing. What I mean to say is that the state of the project directory at C7 should come directly after C3. How do we do that? So for that, there is this command git rebase. I for interactive. I want to do this on top of C3. C3 is the commit, the last commit that I want to keep. After that, I want to straight jump to C7. It brings me to this menu. On command line, obviously, you will not have this menu. On command line, you won't have this menu. It says omit, 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 and omit, and the name of the commits here. It's the order in which the changes were applied. If I do this, it will apply the changes of C5 first and then C4, right? This is for changing the order. If I do omit, what will happen is, if I didn't omitted it, if it was still in the state pick, when I will actually do the rebase, these 4 commits will again be there. Let's do this. I haven't done anything. I just haven't omitted anything. It has created another branch and we still have that same structure. C4, C5, C6, C7. I don't want it. What I want is a single commit. This is how it's done. Commit all the others that you want. So main is at C7 double prime. If I do git commit, it will just go on from here. So after C3, the state of the project is directly C7 double prime or C7, let's say. This is what squashing is. It makes your timeline look a much organized way. It looks a bit nicer in this way. This is all we have done. And this is squashing, how to do squashing. Why is it important? Let's do this in our project. Why is this important? I'll do this git reset. I don't want any changes. Git reset hard. What does git reset do? It restores, it get rid of any uncommitted change that you are trying to make. Okay. So currently, which branch I am on? I am on dev 1. I can do git log graph 1 line. Okay. This is the graph of the project. I don't want all of this to be visible to the others. Whatever happened here, happened here. I want to just get rid of all of this mess that I have created. So what can I do? What I can do is, let's say after this particular navbar heading white state, I directly have this merge pull request state. If I do that, I will get rid all of these commits in between and whatever branching happened. So let's take this. I'll execute a similar command. It shows me like pick and omit, those things are there again. Here it has picked already. The 3 of them are picked. But what did I say? I just want the last one to be there. So what I'll do is I will squash others. When I was showing it through the UI, it was saying omit or pick. But actually, when you do it on the command line, you will have to manually change these to S or squash. Right. I want to squash these commits. I want to just pick one and squash others. Okay. This is a combination of 3 commits. We know this, right? If I commit this entire information will be there. But I just want others to know that not a lot happened. We just added the workflow. That is the last commit message. I just want this to be there. And I look at the graph again. See what happened. It's much nicer. We did some surgery here. We did some operation. None of the things that we did in between, like merging things and creating branches, is visible over here. Understood? We cleaned up the history. This is how you actually clean up your history, that you don't want a lot of commits. Like you might be making small changes and that will be like affecting your workflow. At the end of the day, you can actually squash all of these changes and make a single commit that has done the work of all of those 6-7 commits that we did in between. So that was git rebase and squashing. Let me look at the whatever happened here. Okay, it again failed for maybe for some different reason this time. At least we have the way how to do this. So yeah, can't reach database server at this because there is no database that is actually there, right? This code depends on a database server that is already running to actually compile. So this is the only error that is there. So what would actually be done in these cases? So I'll give you an example. What would have been a valid configuration for this? I just gave it an example, right? Instead of whatever I did there, I should have gone to the secrets. I have these secrets, right? I should have put this instead. This is actually uh, the username and password for some database out there that is running, and it should be accessible. So if I rerun this job, now this should work. So in the pull request, we are seeing some changes. There are some merge conflicts. We covered merge conflicts earlier also. What is a merge conflict? A merge conflict happens. Let's do merge conflicts. When you change the same file at the same location, and two different people have done the same thing, done some changes to the same code, it does not like to merge easily. Instead, what you will get is something like this. This is a merge conflict that says that, see, this is the content that you have. This is the content that the other person is bringing to your machine, bringing to your repository, bringing to your project. But this is at the same line number. What do you want to do? Okay. So what has happened here is, using these equal to, we are separating the content that was there before and the content that is coming now. So these arrows refer to the branch that it is coming from, and the opposite arrows mean that this is what it is currently. In order to resolve this, to just tell Git what you want to do, you actually have to delete all of these things and come up with some new version. Let's say you deleted all of these three different lines. These three lines you have deleted. Then you come up with this, and then you have to commit it again to merge it. This is called merge conflict resolution. So this might also be useful sometime. Okay, so that is there. You can see that the pull request has succeeded, right? Completed job, run yarn build. So the compilation was successful for this project. Now, if someone changes something in this particular project, you can see there is a tick mark here. What does it say? That there has been a successful check that the CI build push is fine. If I get any other new pull request, okay, if I make any other changes and I do any other pull request, so what will happen is somewhere around here, CI add workflow, it will also show that this compilation failed, this compilation succeeded. So you added much more to the project than you were thinking. You added a workflow, you added some way for the owner of this project to actually track what is happening. So these concepts, these things that we did today, this is what happens when you actually contribute to an open source project. This is the way that you do things. And this is what I had to share. So like that completes my presentation. Has any questions or doubts or wants to say something? Now can proceed. Okay. Okay then. I hope this session actually helped you just take a back seat and watch how contributions to open source projects are done in the wild, like on the field, on GitHub. And like I would encourage all of you to actually go to this particular event that's called Oktoberfest, right? Every year DigitalOcean conducts hosts this particular event, Oktoberfest. What it does is like you just have to fix issues or contribute to open source projects, at least 4 of them, within the month of October. So now you know how things are done. You can contribute next year to this Hacktoberfest, whatever event is there, and you will be in a much better position. You will be in a much better position to contribute to projects. So what I'm doing here is adding a new topic to this repository. So I haven't had any progress because I didn't get much time to contribute to Oktoberfest this year. Uh, like all the other years, I have contributed since 2021. So that's there. So right now, I have made all of these changes like pull request, but my repository is not participating. I have not done it for participating in Oktoberfest. I'm doing it for just showing it to you. So when I added this label Hacktoberfest here, now after some time, these should contribute to my progress in Hacktoberfest. So it doesn't have to be a big open source project that you contribute to. You should get started on whatever small projects you find on GitHub. Just explore, or you can also make your own project open source and ask others to contribute to it. So that is about it. And now I'll take a leave. And I hope this session helped you. Okay, then. Bye bye.